In today's modern automobile, perhaps the most important mechanism is the wheel. The wheels reduce friction and allow the automobile to travel along America's motorways with relative ease. How does a wheel reduce friction? The part of the wheel in contact with the ground at any given moment is unable to slip due to friction. This causes the wheel to roll, and when placed on an axle, produces a smooth ride. What if we were to reduce the size and increase the number of wheels? We then have a conveyor plate capable of transporting heavy loads. And if we add a curve to the plate, we then have a round bearing, useful for friction-free rotation. The engine of your automobile utilizes bearings to reduce friction. These bearings use oil rather than wheels, and engineers have employed a principle of fluid called Couette flow to lubricate and overcome friction. Much like a wheel, the part of fluid in contact with a stationary surface will experience friction. But fluid deforms under shear stress, allowing the effects of that friction to be greatly reduced. Here we have a cylindrical vase filled with glycerin. A rotating drum is inserted into the vase. A die is then added to show how the glycerin behaves. See how the fluid next to the drum moves at the same speed while the fluid touching the vase remains still. Much like a deck of cards, fluids can be spread out and stacked back up, allowing for free movement between two objects. Thanks to wheels, bearings, and Couette flow lubrication, Americans can work faster, play faster, and safely overcome friction.